Welcome to puzzle number 7. So this puzzle is just asking for data. And let's kind of jump straight into it. We'll first try with some like dummy data just to see the execution flow. So the first opcode is the call data size. In this case, it's just 1. Then we push 0 onto the stack. Then we duplicate that. Then we copy the call data into memory. And remember, if it's less than 32 bytes, a bunch of zeros will be appended here. So we have like 1, 1, a bunch of zeros. Then again, we have the call data size. Then we push 0. So actually, there's a bunch of like stuff hard-coded here in this bytecode. And then we have this new opcode, create opcode, followed by xcode size. So let's check what create opcode does. So create opcode takes like 3 stack inputs. It takes the value, offset, and size, and it outputs the address. So create is actually used when you want to create like a new contract on the blockchain, and that contract will be deployed at a particular address, and there will be some code associated with that address. Let's check. So these stack inputs, the first one is value. So that's kind of the value in way you want to send to this newly deployed account. Well, you can imagine a scenario where this would be useful. Let's say if you want to kind of if your constructor is payable, so you want to pre-fund your contract with a certain amount of ETH. And then the next 2 stack inputs are actually the offset, byte offset in memory in bytes, and byte size to copy. So these are actually, so you're actually querying something from a memory, and that is the init code for your new contract. But what is actually the init code? Let's I prepared like a simple graphic here just to showcase. So the init or the creation bytecode. So the init or the creation bytecode, it actually contains both the opcodes needed to initialize these state variables, so like storage variables of your newly deployed contract. Then initialize the immutables. Plus, it contains that portion which is your runtime bytecode, or a runtime bytecode can be like simply explained as the bytecode which will always live on that deployed address. So actually, the process for creation of a new contract is the following. In a specific execution context in terms of EVM, you would have this create opcode. It would take those three stack inputs. So the first one being the value, and the following 2 are like the byte offset and the size. So it would take something from memory, and that piece of bytecode taken from memory, that would be pushed into this new execution subcontext. And as soon as you push it into the new execution subcontext, that would kind of start executing. And in a typical contract deployment, as I said, that would initialize state variables, initialize immutables. It would push this runtime bytecode somewhere into memory, and then it would return that runtime bytecode from memory to this initial execution context. And then that return bytecode would be the bytecode of our newly deployed contract. So that is actually also described here. Let's quickly go through it. So creates a new contract, and it enters a new subcontext, executes the provided init code, and then resumes the current context. So that's actually what's happening here. So it goes here, it does something, and then it returns the bytecode into the initial execution context. And should this deployment succeed, the new account's code is set to the return data resulting from executing the init code. So always your account's code is this return data. So this new subcontext needs to return something. And this destination, in case of create, this destination address is like dependent on the sender address and the sender nonce. Okay, so what can go wrong here? Basically this new, so this thing, something can revert here, in which and in that case you would just get a 0 back, meaning that basically your deployment has failed. Or if it's like being successful, you would get back the stack output would be the address of your newly deployed contract, and then on that address there would be some bytecode living, and the size of that bytecode is actually the size of the return data you got back from that execution subcontext. So actually there is like a couple of things happening here simultaneously. So in this case, create will like take 0, 0, 1. So it actually, this 1, 1 would be that bytecode which is executed in a new subcontext. Since that's actually doing nothing, so 1, 1 is not like returning anything, we got like 0 onto the stack, so nothing was actually deployed. And then this xcode size is will basically get the size of account's code. So it takes like stack input, it takes the address and outputs the byte size of that code. In this case, basically nothing is deployed, so nothing is returned. Then we pushed 1. We try to equal those two values. Since they are not equal, this will return 0. Then we push 13, and then we have this conditional jump E. And in order for this conditional jump E to jump to this destination and be successful, this would need to be 1, not a 0. So in this case, this is going to revert. So if we kind of take just a step back, this is hard coded. So here we're pushing 1. So the result of this should also be 1 in order for like these two to equal, which kind of means that create needs to create some like a new contract on a specific address, and the size of that contract should be 1 byte, because the xcode size is like just the size of the code. So basically our objective in this puzzle is to feed the create opcode with some init code, which will initialize a contract with bytecode which has one of length of one byte. And just remember from before, so when create2 is pushing something in a new subcontext, and then whatever is returned from that subcontext, that's actually the bytecode of that newly deployed contract. When I'm talking about this new subcontext, it can just be like viewed as like a new playground. So whatever is fed in this create would enter like a new subcontext, which can be like simulated like this, and whatever is returned from here will be like the return data from this create2. So basically our objective is actually just return some like code which has like size equal to to 1. I think a good starting point is just to check like the return opcode. So return opcode takes the offset and basically byte offset in memory in bytes and byte size to copy. So return also, as many other opcodes, it just like expects you know offset and size, and it just kind of returns that. What's actually like interesting about memory is if nothing is written in the memory, and you say from offset 0 return me first like 10 bytes, it will return like 10 bytes, but it will just be kind of zeros. So even to solve this challenge, we don't need to actually write anything to memory. We can just kind of try hard coding certain stuff. So let's just try an example. So let's say we push like 10 onto the stack, then we push 0 onto the stack, and our return is, I think, yeah, F3. So let's check what's happening here. So we first like pushed 10 onto the stack, then we pushed 0, and then we are, as the specification says, we take from offset 0, we take the size 10. And you see this will be a bunch of zeros. Remember, objective in our case is just to return one byte. So the solution here would just be like push that 1 byte, push a 0, and you see our return value would be kind of just two zeros. And let's try this out with our example. So we're running again. So we have the call data size, bigger now. Pushing some stuff, we're copying this whole chunk into memory. Okay, you see, so we have some stack output, so something was created. Let's check what's the size of that, and you see the size is 1. So in this case, we're going to jump to the correct destination. So this would be the solution to the puzzle, but let me just show you that previous example. If we like pushing here 10. So if the return value is like 10 bytes, let's try with that. Just kind of to confirm that this X code size will actually like return a different size of the deployed contract. Okay, so you have some like stack, and you see, so in this case this is 10. So basically the assumption was correct. Again, this was a very simple example. When you actually are deploying a real contract with this like a init code and and you're returning some bytecode, there's a lot of things are going to be happening during this like init phase. In this case, it was rather simple. Just like one more last thought. So the terminology is very crazy around this. So sometimes you will see init code like in init being referenced just this part which is initialized. Sometimes you're going to be this is going to be referenced as a creation bytecode. Then you have the runtime bytecode. So you're going to see a lot of different terms here, but just take into account that create has this whole chunk of code, and then this first part is executed to initialize stuff, and then the runtime bytecode is actually being returned, and that is the code that is living at a particular address. Okay, thanks for checking out, and see you in the next video.